Calculus 2012, question number 2. Here we're going to have to use the trapezium rule with 6 strips to find an estimate for the average number of cars in stock. To do this, first of all, I would look at the limits and see it goes between 0 and 12. So to make 6 strips, that would be a gap of 2. So x starts at 0 and goes up in 2s until we hit 12. We then need the n coordinates. So to do this, we use the table function on the calculator and we set it up and find the values are for 0 was 320, 418, 420, 374, 328, 330 and 428. Now we're going to use the trapezium rule, and the way I remember it is half the width, so that's half times 2. I open a bracket, then I do the first n value plus the last plus twice the rest of the n values added up, and 374, 328, Right, this then all needs just tapping into the calculator. And a little tip I find here, rather than start at this end, people can often make mistakes with brackets. So what I do is I always start off on my calculator, I add these up first, then I press equals, then I times by 2 and press equals again, then I add the first and the last and press equals again, then I finally times 2 and times a half, and that gives me 4488. You then look back to the integral and see they actually only want a 1/12 of the integral, so we do 1/12 of 4488 to give me 374, and this is the average number of cars in stock. And again, you can sort of check your answer mentally, because from question 1 we knew the cars went between 300 and 450, and so this value is sort of in the middle, so that actually works quite well. Part B is now doing the same thing as Part A, but where Part A was the numerical method for integration, Part B asks us to integrate. It's really important here you set out your maths really clearly and you use the correct notation. So the 12th I'm going to ignore all the way through the question until the last line, but that doesn't mean you don't write it. It's there, it just stays where it is and you just ignore it. And so I'm going to be integrating x cubed minus 18x squared plus 81x plus 320, and I mustn't forget my dx. Once I integrate, you lose the dx in the integration sign and we go to square brackets. So using the normal rules of integration, I'm not actually really thinking too hard about simplifying anything at this stage, because your calculator can do it for you. I'm concentrating on getting my powers correct. So I write my limits now at the end of the square bracket. Now I know the rest you can just do as a calculator exercise, but the example don't like that. They'd like to see some working. So the first thing you do is rewrite out the equation, substituting in 12 for x, and again, don't worry too much about simplifying unless it's really easy, because you don't want to make a mistake because you're focusing on doing maths rather than getting the algebra right. And then when I substitute in 0, it's really nice because there's an x term, in every term, then the whole thing will go to 0. be careful with that, because sometimes if there's a v to the x, it wouldn't go to 0, so it's not always true to say that. Right, I would actually be happy then if I actually showed the exam board. I could actually calculate a few terms. So going through each term, I'm just writing out the long answer, but I've just simply put it into my calculator. I'm going for safety here. I need a square bracket because the 12 deals with everything. And finally, I'm back to here, and that looks promising because it's the same answer as part B. You could also, though, in any integral, you just type this into your calculator, the integration button, and you can check your answer. Part C takes a little bit of thought. It asks us to explain why the average number of cars in stock in A and B do not help Arthur find the total number of cars. And I think you can see this by, if we actually look at the graph, then these are individual days along the x-axis. So for instance, on day 0, we had 320 cars in stock, but if you go to day 9, where there were 320 cars in stock, we don't know if they're the same cars or different cars, because cars stay in the garage for a number of time. Then it's difficult to know, is it the same car or not, so we don't actually know the average number of cars in stock during the whole year.